Hello everyone, welcome back to part 2 of the review of the Australian Big Science Competition mock paper. So now we are at question number 16. Alright, questions 1 to 15 have been covered in part 1 of the video. So if you have not done questions 1 to 15, please go back to part 1 of the video and refer to the review of those questions. So let's begin with question 16, which will cover Alzheimer's disease. So as covered in part 1, the Australian Big Science Competition has a lot of context to read before you start the question. So one thing to read for is always the definition. So Alzheimer's disease, you are told, is a condition where the nerve cells in the brain and spinal cord are no longer able to transmit electrical messages down the cell quickly. And this results in a degeneration of movement and control functions of the body. Alzheimer's disease generally affects more elderly than younger people. Now, importantly, you realize it's about electrical messages. It's about nerve cells. So this, of course, is the nervous system of the human body. Now, electrical messages here is important. This means that the messages are transmitted by electricity. So this will be important because now you are told nerve cells are protected with a myelin sheath, which is a thick layer of fats to ensure electrical messages can be transmitted quickly. So the myelin sheath is fats, and the fats ensure electrical messages transmit quickly. And this is because fats are insulators of electricity. Because they are good insulators or poor conductors of electricity, they help to ensure there is no loss of the electrical message as it travels down the cell. So scientists hypothesize that demyelination, which is destruction of this myelin sheath layer, might be a contributing factor to Alzheimer's disease. So you are shown diagrams to show how the passages of messages can travel down the nerve cell. Alright, and in the nerve cell with demyelination, where the myelin is damaged, the messages are distorted or even lost. So now, because we know it's about nerve cells, it's about the nervous system. So question 16, answer is D, nervous system. Question 17, what can be concluded about the myelin sheath? Of course, the myelin sheath is an electrical insulator. It's about electricity here. Alright, now the other statements are not true because the myelin sheath cannot be replenished. If it can be replenished, you would not have this problem of Alzheimer's disease, right? Because the myelin sheath, if it can be replenished, your nerve cells will never be damaged. Next, the myelin sheath is not the cell membrane of the nerve cells. Even without the myelin sheath, there's still a cell membrane. And finally, the myelin sheath is not a single layer. It's a very thick layer that wraps around the nerve cells. Alright? Now, finally, question 18. What are the possible challenges to verifying the scientist's hypothesis that demyelination is responsible? Challenges means what? More difficult. What might make it more difficult to prove the hypothesis that demyelination is responsible for the disease? This is what we are asking. Which factors make it more difficult to prove that? It is not whether the challenge is real or fake. It's about whether it's going to make it more difficult or not. So now let's read. Factors such as age, diet, and genetics also affect the health of nerve cells. This means these are other factors which affect the health of the nerve cells and the myelin sheath. There are other factors other than myelin that affect the nerve cells. If there are other factors present, it makes it harder to prove the hypothesis. You cannot say that, oh, it must be the myelin sheath, because there are other factors like age also. Next, scientists have discovered that the production of myelin declines as humans age. This means that it proves the hypothesis, because you are told elderly are more likely to have Alzheimer's disease. Right? If the elderly are more likely to have Alzheimer's disease, and you now know that elderly have less myelin, then you can link the two together. Less myelin means more Alzheimer's disease. So it actually helps to prove the hypothesis. That means it is not more difficult, it's less difficult. Alright, sorry, I got it wrong. It's no. It's not a challenge. It helps to prove the hypothesis. Alright, so this helps to prove. It's a help, it's not a challenge. And finally, a recent discovery that destruction of myelin might trigger destruction of more nerve cells. So again, this helps to prove the link between myelin and the nerve cell health. So again, it's not a challenge. So the answer is D for question 18. Alright? So now let's move on to question 19 to 21. So 19 to 21 is about Newton's cradle. So you are told a Newton's cradle has 5 metal balls in contact with each other. Alright? And importantly, you are raising the ball A to a height and released. It hits ball B and transfers energy. So this is about transfer of energy. So now you can ask yourself, when you raise something to a high height, the energy is GPE. Alright, so the answer for question 19 is C, gravitational potential energy. Alright, of course, as it falls, the gravitational potential energy is converted to kinetic energy. Next, which observation will best demonstrate the principle of conservation of energy? Alright, so let's read the statements. But first we need to know, principle of conservation of energy states that energy cannot be created or destroyed. It is just converted from one form to another. So let's copy the main phrases. Cannot be created or destroyed. It's only converted from one form to another. Taken together, this means the total energy remains the same. Alright, so now let's read the statements. Which observation shows you that it cannot be created or destroyed? It's just converted and the total energy remains the same. So if you read statement A, ball A hits ball B and produces a sound. This only proves that there's conversion of energy. It doesn't show you the total energy remains the same. So A is not a very good answer. B, ball C remains stationary when ball A hits ball B. This doesn't show anything. Just because it's stationary doesn't mean there's no transfer of energy. Similarly, C is incorrect. Ball D does not move. Does not move means remains stationary. Again, that doesn't demonstrate that there is transfer of energy and the total energy remains the same. Same height as the original height will help to prove that the total energy remained the same as before. Alright? And finally, question 21. Which change to the setup would increase the height that ball E rises to? Increase the height means more GPE. Alright? Why would it have more GPE? By conservation of energy, we need to know. If there is more GPE for ball E, that means it had more energy to start with. Alright? So, could this change increase the height that ball E is raised to? Let's read. The mass of ball E is decreased to become half. If the mass is decreased to become half of ball A, this means automatically that it's lighter. If it's lighter, by definition, with the same amount of energy, it could raise to a higher height. So yes, lighter, therefore a higher height that it could raise to. Next, if I raise the original height of ball A to a higher height, that means there's more GPE at the start. So yes again. Okay? Next, both balls A and B are raised to a height and released together. More mass at the start, more GPE also. So again, it will help. And finally, if the Newton's cradle is conducted in a vacuum, there is no air resistance. Vacuum, there's no air, therefore there's no resistance, no frictional force with the air. Frictional force with the air is called air resistance. So in a vacuum, there's no air resistance. If there's no air resistance, there's no loss of energy to the surroundings. Hence, it will also ensure that ball E has more energy to be raised up to a higher height. So the answer is D. for question 21. Alright, so let's move on to question 22. Now, question 22 is about planets and orbits, so the big science competition will also test you on the solar system, which you have learned before, even in primary school. But even if you didn't learn it, again, reading the passage helps a lot. So you are told planets orbit around the sun. The time taken to make a complete revolution is called the orbital period. Orbital period is the time taken for one full revolution around the sun. Then you are told another term. Planets do not all follow circular orbits. Most planets follow elliptical orbits, which is oval shape. Oval shape is called elliptical, okay? So, the deviation from circular orbits is called the eccentricity of the orbit. If it's perfectly circular, it's 0, the eccentricity. But if it's elongated, it's 1 maximum. So now you are given a table of data. Whenever you are given a table of data, you should always look at the trend. From Mercury to Saturn, obviously, is further from the sun. If it's further from the sun, let's look at the other two columns. Is orbital period affected or is eccentricity affected? If you just look, the orbital period increase. That means as the planet becomes further away from the sun, the period, the time taken to orbit the sun increases. And this is a consistent increase. There is no exception to this. But if you look at the eccentricity, is there really a trend in the numbers? Can we say the eccentricity increases or decreases? You can't. There is no clear link or trend with the distance from the sun. Right? You can't say that as it becomes nearer or further away from the sun, the eccentricity increase or decrease. You can't say that. And therefore, that will allow us to answer question 22. So you can see that question 22 is about trend reading. Even without studying, you can do question 22. You are told Neptune, a different planet, is further away from the sun. What prediction can you make about Neptune? Can you predict the eccentricity? We just said there's no clear trend for eccentricity. That means there's no clear trend on whether it's circular or elongated orbits. So A and B are out. The only prediction you can make is further away, increased period, a longer period. And therefore the answer is D for question 22. So you can see the big science competition is about reading data, making predictions based on the data's trends. So whenever you are given a table of data, always make it a point to write down the trends like I have done. Alright? Next, question 23. The eccentricity of the Earth's orbits around 0.017. Which statement is likely to be correct? Alright? So now, eccentricity is about how elongated or circular the orbit is. Does that have anything to do with time to orbit? The time to orbit is called orbital period. We just learned in the passage above. If you look back at the data, is eccentricity related to the distance? Is eccentricity related to the orbital period? And the answer is no. There is no clear trend with the distance or the orbital period. So A and B are out. Alright, so you're left with C and D. So now let's look. C and D probably will be the answer, right? It's about the difference between the amount of sunlight received between the northern and southern hemispheres during their respective summers. And that has something to do with a circular versus an elliptical orbit. If it's perfectly circular, there should be no diff in the sunlight received between the north and the south. right? Because the distance from the sun will be the same for north and south. However, if it's elongated, then there is a difference. So now, Earth is 0.017. Mars is 0.093. 0.093 is more elongated. So Mars has a more elongated orbit than the Earth. If it's more elongated, then there'll be a greater difference for Mars. Earth is less elongated, so it has a smaller difference. Okay, so again, it's about deductions. There's no need to study per se. You just need to read the context carefully to realize that an elongated orbit would result in a larger difference between the north and southern hemispheres in terms of the amount of sunlight they receive. And finally, it is extremely difficult to actually measure the properties of planets beyond Saturn. So again, what factors might make it more difficult to observe the planets beyond Saturn? Remember, planets beyond Saturn are very far away. So if it's very far away, of course, it's more difficult to find them, to observe and measure them. Next, the planets beyond Saturn receive and reflect very little sunlight. Again, it makes it very difficult. Simply because, alright, if they reflect very little sunlight, you can't see them very easily. You cannot observe them. You can't even find them, probably. Next, the planets beyond Saturn are much smaller than Saturn. Again, if they are very far away and very small, it's very difficult to find them. Finally, the planets beyond Saturn all have less circular orbits than Saturn. Less circular orbit means elongated orbit. Elongated doesn't have anything to do with difficulty, right? Elongated or circular is just a property of the orbit. So it does not make it more difficult to observe. So the answer is A for question number 24. Elongated doesn't make it more difficult to observe. Alright? So now moving on to question 25 to 27. Question 25 to 27 is about this thing called mammals. I'm sure you know what mammals are. You've learned this in primary 3. Mammals have hair as the outer covering. They are warm-blooded. Okay, they produce milk. So these are typical properties of mammals. Now, an interesting observation made by biologist Alfred Russel Wallace in 1859 was that there was a startling dividing line between the mammalian species on Indonesia and Australia. On one side, you have tigers and monkeys. On the other side, you have monotremes and marsupials. What are monotremes and marsupials? You are explained here. The monotremes are over here. Now, monotremes are like platypus. They are still warm-blooded, they are vertebrates, but they lay eggs and have hair as the outer covering. They produce milk. So now you're asked, which behavior of the monotremes or platypus is different from typical mammals? So now you're going to think back to primary 3. What did you learn about typical mammals? Typical mammals are warm-blooded. They are vertebrates, they have a backbone. They produce milk. They have hair as the outer covering, and they give birth to young life. So based on these typical mammal properties, which one does the monotreme not have? It's this one, right? The platypus lays eggs. That's different. Alright, the platypus lays eggs. Even though it's a mammal, it lays eggs, which is quite different from other mammals. And this already tells you that the platypus probably is very, very different in terms of evolution, very far away from other mammals in terms of evolution and species. Okay? So to question 25, the answer is B. Now question 26, marsupials are animals on Australia that give birth to their young prematurely, and the young continues to develop in the pouch of the mother. And a kangaroo, you might have learned before, kangaroos, the young of the kangaroo actually, the joey, it's called a joey. The joey of the kangaroo develops in the pouch of the mother. What is an advantage of this? Advantage means good. What's so good about this? Alright? Does this make the young less vulnerable to disease? Probably not, right? If the young is premature, it's more vulnerable to disease. Next, the young can develop more quickly in the pouch. That's probably incorrect, right? Just by being in the pouch doesn't make him develop more quickly. Next, the mother can continue to produce milk over a longer time. Nope, that's probably untrue as well. Being in the pouch doesn't have anything to do with the duration of milk production. So the answer is D. By giving birth to the young prematurely and developing in the pouch of the mother can now run, jump over a longer and larger area to find food. And so the answer is D for question 26. Now, question 27 is about the Wallace line, the dividing line between Indonesia and Australia that divides the mammalian species. So why has the line continued to persist? It's because the mammalian species on both sides do not breed together to form offspring. If they had bred together, they would have exchanged their genes. The offspring will have a combined genetic makeup from both father and mother. So, the fact that these two groups of animal species have continued to diverge and be different means that they do not breed together. So this is very important. They don't breed together. And which factors might contribute to this? So again, the mammals are not good swimmers. If they are not good swimmers, they cannot cross the divide. The dividing line is in the sea. If they are not good swimmers, they cannot cross the divide. That means we continue to ensure they don't meet, they don't breed together. So this helps to contribute to this. Next, they have different mating periods. If they have different mating periods, they mate at different times of the year. So again, we ensure they do not mate together. It contributes to them not mating and breeding together. Next, the mammals are each adapted to their current habitats. So again, if they are adapted to their current habitats, it ensures they stay where they are, it ensures they don't migrate away, it ensures that they don't encounter one another as they migrate. Therefore, they do not breed together. Finally, the mammals are vulnerable to diseases on the other side. Again, it contributes to them not wanting to come together, to mate, to breed. Alright, so the answer is D. I'm so sorry, the answer is D. Alright? These are all factors contributing to the species not mating together. Now let's finally move on to the last context, the last set. It's about Einstein's thought experiment called the lift. Albert Einstein once suggested, famously, that a man in an enclosed lift on Earth actually cannot tell whether he's stationary on Earth or accelerating upwards in a region where there's no gravitational field. Now, how does that work? Now, if the man is in an enclosed lift stationary on Earth there's weight. The reason why he doesn't crash through the lift floor is because the floor of the lift exerts a force on the man, and this force is numerically equal to the weight of the man. And so this is a case of balanced forces. When the forces acting on an object are balanced, the object remains stationary, not moving, or moving at constant speed. Okay? So now, if the man is in the same enclosed lift accelerating upwards in a region without gravitational field, without gravitational field means there is no weight. There is no weight on the man. Okay, there's no downward force. Alright? So in this case, there's only an upward force. There's no downward force. There's only upward force. So if there's only upward force, of course it's unbalanced forces. So unlike the previous case where it's on Earth, there's a balanced force, a set of balanced forces. But in the second case, where it's accelerating upwards, accelerating actually means unbalanced forces automatically. Okay? So now let's look at the question. Question 28. Which statement about the forces of the man in the enclosed lift on Earth is correct? There's no force acting on the man. Wrong. There are forces. There's a downward weight and there's an upward force of the lift on the man. So, based on this, the answer is D for question 28. The two forces are balanced. The upward force is numerically equal to the weight of the man, which is acting downwards. That's why the man has balanced forces and the man remains stationary for question 28. For question 29, the man in the enclosed lift now accelerates in the upward direction in a region without a gravitational field. Again, it's not that there's no force, right? It's that the only force acting on the man is in the upward direction, because without gravitational field, there is no weight. If there is no weight, there's no downward force. So the answer definitely is not C or D, because C or D must have weight in there. Okay? And finally, this was a thought experiment by Einstein. It eventually formed the foundation. His thought experiment formed the foundation for his theory. So the idea is, if it's a thought experiment, is it existing knowledge that you are applying? No. You are not applying existing knowledge. You are thinking about your existing knowledge. You are reviewing existing knowledge by thinking through it. Okay, you are reviewing existing. Oh, sorry. Sorry, I'm wrong. Sorry. Correct that, okay? So you are using existing knowledge. So applying means using existing knowledge. And you are using existing knowledge to discover new theories, new scientific knowledge. So the answer is A. Now, what is this word technology? Technology refers to the application of science to devise new solutions to problems. So, for example, artificial intelligence is a form of technology. You are applying science to devise a new solution to a real practical problem. This is not. This you are actually applying existing knowledge to discover new knowledge, which is a theory, a new theory. Alright, so the answer is A for question 30. And this brings us to the end of the review of the big science competition. Now, what's very important really is not the knowledge itself. What's very important is the skill to read the context, highlight the key definitions, annotate the key terms, the key trends in the table of data if you are given a table of data or graph. So it's very, very important that you read carefully, highlight and annotate carefully. And I hope you will do that during the competition as well. Alright, thank you so much.